Boom. Hello and welcome back to Calculus 1, section 5.2, definite integral. I know that I already showed the Riemann integral in the previous section. So we already know that the limit as n goes to infinity, summation 1 to n f of x n dx is the integral a to b of f of x dx. Do you all remember the limit definition of the derivative? Limit h goes to 0 for f of x plus h minus f of x over h.
I tried really hard to do that.
Yeah. So that was the limit definition of the derivative. Think of this one as the limit definition of the integral. Okay? You do that?
So that means we'll never use it again, right?
Well, you use it today. Of course you use it. We're going to compute exact area under f of x squared minus 2 on interval, what was it, 3 to 7? Yeah. Compute the exact area. May I add using Riemann sums. Good luck with this one. All right, so we are supposed to use the limit definition of the integral to solve this problem. Let's see how that works. So we have a function that goes from 3 to 7 with these rectangles in between. But now I'm going to have infinitely many rectangles. And if I am to pick any of these rectangles as a representative rectangle with the delta x, this guy is going to be called representative rectangle. I'm going to compute values here. We know that a is 3, b is 7. So I can quickly compute that delta x is b minus a divided by n, which is 7 minus 3 divided by n, which is 4 over n. I cannot write the number of rectangles n because I'm going to let that n go to infinity. So I just have to leave it as 4 over n. So delta x is 4 over n. That's the first part. Now I have to figure out all of the values that go into a function. So how would I do that? What is the xn equal to so that I can create those f of xn? Well, no, this is a subscript. This is x0, x1, x2, x3, x4, x5, so that I can eventually have this. Now, what is this xn? How do I deal with that? Well, all of these xn values will be a plus delta x times some counter I. This is not complex I. This is just value, the counter, right? So that's here. Ooh, now I see the issue. Okay. I goes from 1 to n, and this is xi. All right. N goes to infinity. So fix the notation up there. Go all the way on the top of the page and fix the notation where the counter is I. I is gonna go from 1 to n, and then, or 0, or whatever number, doesn't matter. And then you have xi. That's your counter. So we are actually working on the xi. There we go. Much better. So I is a counter, which is 1, 2, 3, 4, 5, and going on forever. Now, does this make sense? Xi to be 3 plus 4 over ni. I hope you see that it does. Because if the function goes like this, and this is your a, then the next number is going to be a plus delta x, and the next number here is a plus 2 delta x, and so on. Because each one of these is delta x. If you think about it, you start with a, in our case 3, and when you add delta x, you arrive to the next value. If your delta x is 1, it will be 4. If your delta x is half, it will be 3.5, and so on. So you have a, and you add 1 delta x to get to the next point. Then you add 1 more delta x, which is 2 delta x altogether, to get to the next point. Then 3, then 4, then 5 to get to the next point, and the next point, and the next point. So this formula makes sense. You start at a, whatever number that is, and then you, first time around, for the first sum, you add 1 delta x, then for the next one, 2 delta x's, then for the next one, 3 delta x's. So it's a counter. It's a counter. You haven't seen stuff like this before. This is called discrete mathematics because it's not continuous. It is that your input is 1, 2, 3, 4, 5, and there are going to be 2 chapters of this stuff in your Calc 2. Chapters 8 and chapter 9 that deal with similar stuff. So what have I found so far? I found what delta x is because I have the formula for that, and I just plugged values in. I know b is 7, a is 3, and then n stays as n because no one gives us number of rectangles. We're going to shoot that to infinity eventually. Once I have delta x, now I have to figure out what's f of xi. So I have to first figure out what xi is. This is the formula for xi. And then you plug in your a and your dx, delta x. All right, so now I have those two. Next piece of information is to create f of xi. Well, I know that f of x is x squared minus 2. So to create f of xi, I will plug in xi, so that's 3 plus 4 over ni squared minus 2. Now you work that out. It becomes 9 minus 24 over ni plus 16i squared over n squared, and then minus 2 at the end. So f of xi is going to be 16i squared over n squared minus 24i over n plus 7. Great. Next step in life. Next step in life is to plug all of this into the formula, the limit. So we know that the formula says limit n goes to infinity, summation I starts at 1 goes to n of f of xi times delta x. Well, you know what these things are now. So limit n goes to infinity, summation of, and we are going to write 16i squared over n squared minus 24i over n plus 7. Everything times delta x, which was 4 over n. Summation goes I1 to n. So we will finally manage to set up. So this is the setup right there. And now we just have to solve this. Holy nightmare, right?
Yeah.
You are looking into this, and it's like nested operators. You have the summation whose variable is I, whose output is n, and then limit operates on that n. So, wow, right? What I'm going to do is I'm going to distribute 4 over n to each one of the summation terms, because we know that addition, sum is addition, and you can distribute into addition. And then I'm going to split this over 3 sums and use conversion formulas to get rid of sums. Not conversion formulas, to actually add all of those sums. And once I add all of those sums, I will have just a basic chapter 2 limit to deal with. So where do we begin? Distribute, right? So the first step is distribute. I get limit n goes to infinity, summation I goes from 1 to n, and now in parentheses I have 16 over n cubed, and I'll put I squared on the side, minus 24 over n squared, and I'll put I on the side, and then plus 28 over n. Now I'm going to say variable is I. Variable, let's go variable for the sum. So now I'm going to split this into limit n goes to infinity, and I'm going to write 3 separate sums. But since this sum operates only on i's, I'm allowed to, well, let's do one step at a time. 16 over n cubed I squared minus the summation of 24 over n squared I plus summation of 28 over n. All of these summations go from 1 to n. And now I'm going to kick out all of the non-I things, because the variable is I. So that's the one that cannot escape the operator, but everything else can, because in the i's of that operator it's a constant. So 16 over n cubed can be kicked outside, and I'm left with summation 1 over n of I squared minus 24 over n squared summation of I plus 28 over n summation of just number 1. That's the only thing that stays. Now I will write in, I guess, purple. We don't have to scream it. In purple, I will write the formulas. Summation of I going from 1 to n of constant is just going to be Cn. That's all it is. Another formula, summation I goes from 1 to n for just I. That's going to be n plus 1 over 2. Summation of I squared, that's another one we need, is going to be n plus 1 2n plus 1 over 6. And then there's one more formula for I cubed, going again from 1 to n, and that's going to be n squared n plus 1 squared divided by 4. So we're going to use these formulas to simplify everything. So limit n goes to infinity, and we have 16 over n cubed, and now you have I squared. So instead of I squared, I will be writing n plus 1 2n plus 1 over 4, no, over 6, minus 24 over n squared, and then I is n plus 1 over 2, and finally plus 28 over n, and that's just c times n, which is just n. If you carefully observe, no more i's in there. Now this is your chapter 2, right? These guys die, and as n goes to infinity, you just look at the front exponents, right? So you have, well, 16 and 60 will cancel down to 8/3. So you have 8/3 n plus 1 2n plus 1 divided by n cubed minus one of the n's drops. That's going to be 12 n plus 1 over n, and then plus 28 at the end. You know what happens when you have same exponents on top and bottom, right? You have n, so this is like 2n cubed over n cubed. So 16 over 3 minus 12 plus 28. That's 16 over 3 plus 16. 16 times 3, 48. So 16 plus 48 over 3, which is 64 over 3. Is that what we had before? That was in previous lecture, right? No, that's not what we had. 97 and 1/3.
That's just me.
Yeah. All right, so there's an error somewhere. So we erase everything and then start.
Yes.
So the problem was 3 to 7, right?
Yes.
Yep, 3 to 7, x squared minus 2. And over here we have 3 to 7, x squared minus 2. Yes. So now that's a 4 over n, that's 4 over n, that's 3 plus 4 over n I, that's all good. Alright, so now let's see the foiling over here. 3 plus 4i, 4 over n I squared, that's the x squared, right? And then you have minus 2, so that's 3 squared is 9. 3 times 4 is 12. Double that, 24. Oh, why do I have a minus there? That's a plus. Okay, so if that's a plus, oh, that's an easy fix then. That's a plus. And we'll just propagate down. Plus, 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 plus. So 12 and 28 is 40. 40 times is 120. Well, this is 16 over plus 40. That's 120, 136. Still not good, right? There's still one more mistake somewhere. Because now it's too much. What was the other one? 292 over 3. 292 over 3. Alright. So that was the plus. Let's see how the calculation goes. Alright, so now square it. That's gonna be 9. 3 times 4 times 2 is 24 over ni. Plus 16 I squared n squared, and then you still have this minus 2. So that's 16 I squared n squared, 24 and then plus 7. Good. So now we go down, plug everything in, times 4 over n. Distribute 4 over n. So when I'm distributing 4 over n, all of this should be 4 times, right? So I did 28, but I didn't do 24 times 4, and I didn't do 16 times 4. Do you see that? So what's 16 times 4? 64. And what's 24 times 4? Exactly. 96. So we have a 64 over here, 96 over here. So 64 over here, 96 over here. So this is supposed to be 64. And when I cancel it by 3, it becomes, no, if I cancel it by 2, it becomes 32. So that's 32. And the second one is 96. That one doesn't cancel. What cancels with this one gives you 48. And the last number is good. Alright, so now calculate this one more time. So this is gonna be 36 times 2, 64 over 3, plus that's 48, and then plus 28. So this should work. 64 over 3 plus that's over 3. So 48 times 3, 144, plus 28 times 3 is 84, right? So I have an 8, and I have 13, and now if you if you add these, you end up with
Different number.
a different number again. Yep.
Wait, what? I got 292 over
292.
3, right? Yeah. And I over a different number.
But no, this is more. It's 292. This is 302. So there's something to fix still.
48.
Plus 28. What is it?
48 plus 28 times 3 is 228. Yeah.
Oh, 228.
Yeah. Plus 64 is 292.
So 292.
Yeah. 292.
So just two of these on test and hours done. So I will do one more. Try to try to do it right. And then after that, problem dodgeball.
Yes. We should have also started dodgeball. Up. I agree. Let's walk and discuss math. You know.
All right. So after this, we're going to go one floor down and make one loop on the
Yes, that'd be great.
out by the cafeteria, and then come back.
No,
What?
fine, but I'm fine with it.
We can all walk, Brian will run twice around.
That's
Yes.
fine.
Oh, you have the workout routine? All right, we'll do the workout routine then. Should have started that from day one.
Yeah, for real. It'd be like so late. And then we come back here.
I know.
Yeah, right.
I talked to Amanda on the during the
Interesting.
induction, and I said, well, stop by for Saturday night.
Yeah, no, she was like so against it. Why? Like, she's mad about this. Like, come, like, stop, like, she spends hours on just something physical. A lot of running around, you gotta use your mind. No,
Dude, you got to come up with a building. Yeah. Oh, the pit. You need to design like the pegboard in the building right here.
All right, so I'm going to challenge you guys.
Yeah, I was gonna say you did one.
I'm going to challenge you to see if you can set up. So we're doing the same problem. It's going to be x squared because we don't want to stay here forever. We can do x cubed, then just leave at 5 p.m. But I'll have stuff scheduled, so I can't have to get out of here. So let's see how we do the problem. So let's say that f of x is x squared plus 2x minus 3 on interval 1 to 6. It really doesn't matter, right? Because so same as before, delta x is first. So figure out delta x first, then figure out xi, then figure out f of xi, then plug in, and sum, and then after that you have about 20 minutes and the problem is done. All of a sudden that limit definition of the derivative was awesome, right? The integral was a little bit of trouble.
It's like various degrees of suck.
Yeah. That's okay, I'm just gonna sit somewhere in the back. You should collaborate, check your answers, and check everything against the previous problem. I'll be with you in like 8 minutes.
Whenever you want, right?
Suffer a little bit, you know. That's right.
That was the original problem. Because it was like US minus or X squared minus 3. Like in this one, I'll have the minus 30. How far did we get? Mm-hmm. Oh, how far did we get? It's just like how it is. Let me get the part where you need to substitute I, because I have a question on that. Oh, let's keep it something simple. Yeah, that's amazing. I'll do this and do it again. Yeah, it's amazing. To do one? Oh, what the hell, man?
Begin with them all. Let's take a look at this together. Delta x is b minus a over n, which is 5 over n. Xi is a, which is 1, plus delta x, which is 5 over n times I. f of xi is when you take xi and plug it into f of x. So it becomes 1 plus 5 over n I everything squared plus 2 times 1 plus 5 over n I minus 3. And this is the algebra that we actually have to work out to simplify as much as possible. So FOIL the first one. 1 plus 10 over n I plus 25i squared over n squared plus 2 plus 10 over n I minus 3, I hope. 25 over n squared I squared. We kind of know that this I needs to be on a side, right? Because we will be factoring eventually 25 over n squared. Then 10i, that's a 20 over n I. And then 3 and 3, they all cancel, right? Do they? They do. So now I have all three pieces which I need to plug into the formula. I will remind you that the formula was limit n goes to infinity, summation I starts at 1 goes to n, and here is your f of xi, and here's your dx. So I will have limit n goes to infinity, summation I goes from 1 to n, and instead of f of xi, I have the 25 over n squared I squared plus 20 over n I times dx, which is 5 over n. I will distribute 5 over n, then split the sums, then replace the sums and be done. So this becomes summation 1 over n of 125 over n cubed I squared plus 100 over n squared I. Now we're going to split and kick these in front of sums. Well, let's split, do 2 steps at a time. I mean 1 step at a time. So 125 over n cubed I squared plus summation, again, y 100 over n squared I. That's going to be limit n goes to infinity. And then what you have here is 125 over n cubed summation of I squared plus 100 over n squared summation of I. So what you are doing here, guys, is you are kicking this 125 over n cubed out because summation is the operator which operates on I. I is the main variable. All other variables are constants in its view, so you can kick them outside. So now I have the limit of the whole thing. And this is where we use those formulas which I wrote earlier. So now limit n goes to infinity, I have 125 over n cubed, and instead of I summation of I squared, I have the good old n plus 1, 2n plus 1 over 6. So I should, let me color code. So this thing is this thing. So that's equal, all right? Plus 100 over n squared, and instead of summation of I will write n plus 1 over 2. Let's box that in blue. So that's that. Now I have the limit n goes to infinity, 125 over 6 n plus 1, 2n plus 1 over n cubed plus 50 n plus 1 over n squared. Now, as you can see over here, I don't care about foiling everything and doing the limit because only the front coefficient, right, the highest exponent of x matters. If they're the same, take the front coefficients. If the higher one on top, it's infinity. If the higher one on the bottom, it's 0. So I have n times 2n, that's 2n cubed. So this is technically 2n cubed over n cubed. It's 2. So the limit is 250 over 6 plus 50. 250 over 6 cancels down to 125 over 3 plus 150 over 3 is 275 over 3. You like it? Of course you love it. Plus it's Saturday, so you enjoy this double, right? Because you love weekends.
It wasn't as bad as the first season.
Yeah.
Yeah.
You've seen it the first time, and now you've seen it again, and the cool thing is that you don't have to worry about this anymore. You've seen it, right? Because now we just say,
We do the better way.
or integral 1 to 6 of x squared plus, what was it?
30.
No.
No, 2x plus 3.
2x minus 3.
Or, yeah, plus 3. Isn't that?
Dx. So that's going to be x cubed over 3 plus x squared minus 3x from 1 to 6. We plug in 6 first, so that's 36 times 2, 72 plus 36 minus 18 minus 1/3 minus 1 plus 3. Here, I'm fast at calculations. I'm insanely good at this stuff. So actually, that's not correct. Something is wrong. Because over there, oh no, it's good. Minus 1/3. All right, so now we can do one of those, when you go to check your prescription for glasses and lenses, and they say what's better, A or B, right? A or B. So what's better, A, or wait, let me scroll, or B? What?
And they're like, is this one better or is this one better? They look the same.
And it's like, I'm just blind
Yeah.
in general. Just like,
No, you just have to, the trick is to wait 10 minutes to see which one is going to cause you headache.
Oh.
So I stall.
I think I got my prescription.
That's why, yeah.
Simple.
Or just don't get your vision bad.
Yeah, let me work on
Wait
that.
for
still have
me.
bad vision.
Is
Yeah,
it too
just
late?
don't, yeah, and you'll be fine.
It's your fault.
It's okay, I'm waiting for those eye implants.
Eye implants?
Yeah.
Just get LASIK surgery.
Yeah,
My brother did.
You know that isn't
Alright, so I'm going to stop the stream